Welcome back, and let me see if I can make this tolerable. Not spend half your life listening to me. Number one, we are going to start doing some serious building now. It's intermixed with building the transceiver or designing and laying it out. I'm going to intermix some test equipment. Now, if you're new to building anything at all and new to the toner transfer and you're learning it, I'm going to give you some startup projects that will consume some time and some parts. And just part of the training process. There's a side business to this toner building, and that is because you've got a single-sided board, you do not have plated through holes. When you solder a component into place, there's only one solder joint, and it's very, 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 very easy to pull the part out. You can pull the part out if you destroy it, throw it away, or you can pull a good part out and save it. Now, don't save them too long, because then you'll wind up with this big old peanut jar full of parts that half of them you don't know what they're for or what have you. So side effect is you easily repair and substitute and experiment, which is the purpose of this exercise. We're going to build an SST using the toner transfer. I built an SST using Manhattan, and I promised that I would share it with the world, but I haven't done it yet because if I just turn it loose, I'm going to get 1,000 questions, and I don't want 1,000 questions. Please. So bear with me. Let's do the let me go through the SST building it toner style so that I can explain everything that's going on, and I won't get so many questions. And you will learn something in the process. So, the SST is a simple superhet transceiver done by Wayne Burdick in 1997. Was going to be an Orcal kit, but Doug Hendricks had too much going on, so he gave it to Bob Dyer. Bob Dyer formed a company called Wilderness Radio and sold thousands of them. You may own one or two or three or four of them. I had a few, but I've given them all away and donated them to the school. So just refresh my memory, we're going to build one from scratch. Well, you're going to need a manual. Well, let's go off here and do, the web has a lot of stuff, so let's look for it. Wilderness Radio SST Transceiver. I've entered this before, but manual. And first thing comes up is this site QRP Builder. Who is that? Let's whoops, that just points to the manual. We'll come back and figure out who did that, but anyway, here it is. The manual, 22 pages. Done in 1997, 1998. There must have been two versions. 22 pages. First of all, if you're not familiar, it's a little QRP transceiver available in 4 bands, 40, extra, general class, novice band, 30 meters, 20 meters. Output up to 2 watts, adjustable from a half to 1, and I've got mine working at 0.95 watts because I didn't want to do 1 because you say, oh, it's 1.01 or 0.0003. Nope, 0.95. Plus or minus 0.001 watt. So it's not going to be a lot of power. And the reason I chose 20 meters is because a lot of below 2 watts, the low band's going to make it tough. And 40 meters you only want to do, I think, in the winter. Summertime, you got too much static noise from thunderstorms. 80 meters in my entire life, I've been licensed on and off since 1957. Pooh. I've never worked anybody on 80 meters. QRP, period. I don't think it's possible. Well, it is possible, but I've had no luck. I don't know what I'm doing. We're going to do 20 meters. Now note, please note, the original design went from 14040 to 055. That's 15 kilohertz. Now, for a lot of you, 15 kilohertz is just going to bug the hell out of you because you want the whole band. Can't do it with a VXO. Now, I got 50 kilohertz, and I'm going to show you how I did that. But I'm not going to show it to you today. You have to come back. Spend the quarter, get your seat, get a bag of popcorn, and sit down for the movie. Now, now let's go through the manual. I'll show you a couple of things here. For the bands, there's a table here for the components for the individual bands. If you want to beat yourself against the wall, go ahead and do 40 meters. Now, I have worked all states on 40 meters at 0.95 watts from Dallas and from Prescott, Arizona. Prescott, Arizona, I had a V-beam. In Dallas, I had an off-center fed dipole at some, what did I have it at? 15 meters or so up, and it took over a year. 30 meters is a little shorter. 20 meters, now that we're in we're starting on the downside of this peak, but 20 meters is good. In fact, the sun is so active it's almost impossible some days, but this winter I expect to do real well. Okay, now let's talk about, I'm getting hoarse. Let's talk about VXO and IF frequencies. The combination of the two determines where the critter is going to operate. It's either the sum or difference of the two that gives you the band. I took on as an exercise myself, me, myself, and I did a list of all the crystal.freqs. I took a list of all the crystals that I could find on AliExpress and some from DigiKey and Mauser. There's probably some more. There's there's a missing of 13.500, which I had at one time. There's probably some more. If you go and make all the combination pair out of these frequencies, I think you get 600 some plus. I don't know. So I wrote a little C program to do the combinations, do the plus and minus to figure out which band the thing would wind up with. And I sorted and printed out the list. And here's what I get. Let's see, how many did I get? Let's do this. I got 72 that are in the bands, okay? 20 meters, these are all the combinations here. If you look, 18.0 and 3.932 is the combination that at the time Wayne Burdick chose. 3.932 is, there are a lot of 4 megahertz, 4.032, 4.06, 4.032, 4.096, 4.0, 3.932. There's a bunch in that area, and they make good CW filters. When you have a choice between IF and VXO, pick the VXO highest frequency of the match pair for your VXO. Two reasons. Low frequency for an IF gives you better selectivity, and a high VXO frequency gives you a greater tuning range. And I used 22.118 for my VXO. 27 won't work because 13 I don't think is a very good filter. Somebody, adventurous spectator, if you have 27, 1-2s, and 13s, try this and report back to us. So I want you to go and figure out what combination, what band you want. And first of all, I want you to build a VXO. Maybe you don't want to, but I would like to see you do it because it's a good exercise. Let me see how I'm doing on my time. 10 minutes, 11 minutes, good. Going back to the manual, look at the schematic. So, and here's the VXO. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So VXO is simple. It's cheap. You can get the crystals for under $1, and if you buy them in quantity on AliExpress, you can get them for 15 cents a piece or so. And you want to get 20 to 50 for your IF if you want to match them. A lot of times I'll just throw, if the crystals are in the same batch and they're active, I'll show you that later, I just throw them together because I'm not that particular on selectivity, because I grew up listening to 40 meters on an Hallicrafter was into what it was, S38, which was, you could tune the whole band from one spot, just you had to use your ears. So this is the parts layout. Now the SST I'm going to build is from this schematic. Kenji JH1PJL had this out on the web, but his website disappeared and it's not on archive.org. I saved it way back, and I'll put it on my web page and I'll point to it. This is one I'm going to use because he got away from the LT1252 video amp, which I can't find without a lot of trouble. So we're just going to use a 2N3904 here. For the PA transistor, I'm not going to use a 2SC799. I'm going to use a, what is the number? 2SC5706. We'll come back. That's why I'm going through this. Here's his VXO is about the same. He just changed values because this is for 40 meters. So get this and you figure out if that's what you want to do, or you want to build the original. And if you have the LT1252 video amp, more power to you. The original design used a 799 or a 3553, and those are both PA transistors that were used in old CB radios. Let's go and bring up Sprint layout and show you how I generated a board a while ago for the VXO. Now my board doesn't have a whole bunch of labels on it. The reason is, I'll show you. For me, I did it in a hurry, so I just put it together, but here's what happens if you go and drag a part onto your board. You get to label it. See, there are two dots here. Okay, let's say this is R5 and it's 100K. These should be lowercase, but everybody uses capital. That's really a 1024. And there you go. This is a 5 millimeter separation between the pads, which is good for 1/8 watt. One of the things, if you do it if you do it this way, you're going to gain something. Let me go back. I showed you how to get the demo copy of Sprint Layout. Demo copies don't do everything because they want you to buy the program, so it doesn't save your work, generate Gerbers, or all that stuff. But one of the things that this does do, this program will generate a components list or a bill of materials. So this is the only part I did this way, so it shows it's part number 1, it's an R5 RD, and then it's its value, which I entered here. But the process of pointing and clicking and whatever takes too much time for me. All right, let me explain this. This bottom section here is the VXO, but I've added here, this is the header for my power supply. I'm going to feed it 12 volts. Here's my LED, green, drop the voltage a little bit. And this transistor looking thing here is the 78L08. Go back to the schematic, it requires 8 volts. Now, Kenji here did his with 6 volts, I think. Yeah, he did a 78L06. So he's running it at an even lower power. But I'm going to do 8. These are the stabilization caps to keep this thing from oscillating. Here's my tuner, potentiometer. Here's R5. Don't have a symbol for a varactor, so it's just a variable capacitor. So here's a capacitor. I could put a line through there so it's variable. Don't have a symbol for the inductor. There is the, what is it, RFC3. Let me go here. Let me do text. Let me do, I don't want big text here. Let me do 1.0. Text. RFC. I'll just show you I can do this. Okay. That's where I can label all these. Now I'll label this before I put it on the web, and I'll give you a pointer to it. So later today, this will take me about 30 minutes to do, less. I'll just label it so you won't get confused or reduce it. Where was I? So, your assignment, build something. Build a VXO, a VFO. You want to get to the other parts of the SST, build a crystal filter with whatever crystals you've got. And you're going to need some test equipment. The more the merrier. You always see the big guys on YouTube. In the background have 35 pieces of Tektronix and HP equipment. We're going to build some test equipment from scratch here during this build. Let's see how I'm doing on, excuse me. Let's see how I'm doing on time. Whoops, come on. How come you didn't minimize? Oh, I got 2 copies here. 18 minutes. Oh, let's keep them under 20. Thank you for your time. I left out some stuff. I'll come back to it. Oh, one of the things, I was having difficulty with the toner, and it's because my Samsung printer ran out of toner. It was running out. I got a new cartridge from Amazon. It's sitting here on the floor. I'm going to install it, and I'm going to go build this VXO and experiment with a couple of other crystals. Let's see if you can reproduce what I get. Thank you very much, and I'll get back to you later today and tomorrow.